Alright, diesel electric road locomotives operating instruction section 3 class EP3 general data locomotives builder electric motor division generator General Motors. The horsepower rating is 6,000 horsepower, gear ratio 22 to 55, maximum speed 98 miles per hour, units per locomotive 2A and 1B, trucks per unit 2, axles per truck 3, traction motor per truck 2, wheel diameter 3, 6 inches, journal size 6.5, 12 inches, brace schedule, Westinghouse 24 RL. Maximum over dimensions: A unit height is 15 and 5 inches, width is 10 and 6 and 7/8 of an inch, length 71 foot 1/4 an inch. B unit height is 14 foot 8 and 7/16 of an inch, width of 10 foot 6 and 7/8 of an inch, 7 foot 70 foot even for B unit length. Total weight: A unit 319,600 pounds, B unit 306,100 pounds. Weight of the drivers 215,400 pounds. B unit 206,300 pounds. Steam generator water supply tank capacity at 1,200 gallons for both. Sand and fuel capacity 1,200 gallons. Sand capacity 16 cubic feet, and B unit none. General data diesel engine make of the model AM electric motor division 567A. Horsepower governed by the revolutions per minute 100 at 1,000 horsepower at 800 RPMs. Type is VE cycle. Number of cylinders 12. Bore stroke 8.5 by 10.5. Idling speed 275 RPMs. Firing order 1, 12, 7, 4, 3, 10, 9, 5, 2, 11, 8, and 6. The number of engines per unit 2, and lubricating oil capacity each for the engine 165 gallons, cooling water capacity each for engine number 1 engine 192 gallons, number 2 engine 187 gallons. Diesel engine, beginning with a two-cycle engine, only the two strokes for the piston are required to complete the cycle for the cylinder. Events exhaust intake for the events for the taking place during the part of the power combustion compression strokes, respectively, since the piston are not required as the function air pump specially designed for blower handling of the large volume of air, low pressure used to supply air cylinders to of these blowers are mounted on each end of the driven of the blower drive gear for the camshaft gear train. On each blower, air intake is mounted on the air filter, removing the dust from the air intake air. The cycle of events for the cylinder of the engine explained with the following 4 paragraphs. The lower end of the downstroke of the piston covering the row of the air inlet ports and the cylinder lining, admitting the blower air into the cylinder from the airbox surrounded by the cylinders. This flow of the air through the inlet port at the bottom of the cylinder's output out through the open exhaust valve for 4 per cylinder at the top of the produce, completely scavenging, cleaning, leaving the cylinder full of clean air when the piston covered the inlet ports for the upward stroke. As the piston continues upward stroke, the exhaust valve will close and the charge for the air compressed for the about 1/16th of its initial volume with about 600 pounds per square inch pressure. Air, when compressed to the extent increasing the temperature in approximately 1,000 degrees Fahrenheit. This high compression is maintained at all loads of speed because the air intake is never throttled. Slowly before the piston reaches the top dead center of its stroke, the full atomized high pressure injected with the combustion chamber, the fuel is ignited with a high temperature of the air continued for the burning until the charge is consumed. The burning charge with the rapidly building the high pressure which acts on the piston, forcing downward in the power stroke. Just before the piston reaches the end of the power stroke, the exhaust valve releasing the combustion gas with the atmosphere of the piston still going down again to uncover the air inlet ports. By the time the exhaust gases have been expanded to the point where the pressure is low in the cylinder, there is an air there in the airbox. The cycle events as then repeated. Main generator, auxiliary generator, engine blowers, and oil separators are mounted on the rear end of the engine. The governor, electro-pneumatic governor control, water pumps, and lubricating oil pumps mounted on the front end. The cylinder arranged with the 2 banks with a 6-cylinder each of the bank within angle of 45 degrees between the banks. The right and left banks side of the engine designated by the right and left hand respectively when facing the rear end of the train. Cylinders numbered from the front to the rear, starting with the number 1 at the end of the right of the bank, ending with the number 6 at the rear of the end of the right bank, beginning with the number 7 on the front end of the left bank, and ending with the number 12 on the rear end of the left bank. The direction of rotating the engine is counterclockwise when facing the rear end of the diesel engine. Diesel engine governor and governor control. The hydraulic type of the governor on this engine contains 4 essential sections. The oil supply, speed control column with the power piston, the compression mechanism. Each section has the definite function controlling the speed of the engine. Special self-contained oil system consists of the storage pump, the rotary gear pump, the ball check valve, the accumulator, capacity of the governor, and 3 pins for the engine. Lubricating oil shall be used for the oil lubricating for the movement parts for the governor as well as the hydraulic medium. To vary the speeds of the engine, throttle change with the maintain with the constant speed, but the load changes the amount of the fuel injected into the cylinders must be varied. The amount of fuel injected determines the piston position of the power piston with the piston determine the spring load, rotating flyweights. Movement of the flyweights causes the change of the position of the pilot valve of the plunger controlling the supply of the oil, which actually actuates the power piston, the engine speed, with the flyweights actuating the pilot valve. Plunger determines the piston with the governor control arm, with the governor control arm change with the pressure for the speed or spring, the control of the pilot valve plunger through the movement of the flyweights, the piston of the governor control arm determined with the throttle lever through the electropneumatic governor control of the weight. The flyweights and the pilot valve plunger are located in the central portion of the governor known as the speed control column. The power piston supplies the force to move the injector control rack with injector linkage. The composition mechanism prevents the engine from the racing of the hunch, from stopping the movement of the power piston over that has been traveled sufficient amount, giving the desired speed. The governor is mounted with the front end of the engine driven through the 90-degree bevel, the gear drive with which is turned, driven, spur gear, accessory driven gear with the train means of the serrated shaft. The drive assembly is lubricated by the engine lubricating through the drilled passages in the housing. Various throttle lever positions and corresponding with the diesel engine RPMs are as follows. Off at engine 0, engine RPMs, idle at 275, and selector and throttle lever 1, 275, throttle level number 2, 350 RPMs, throttle number 3, 425 RPMs, 4, 500 RPMs, 5, 575 RPMs, 6, 650 RPMs, 7, 725 RPMs, and 800 RPMs. The overspeed stopping device for the engine is the flyweight mounted with the right hand camshaft counterweight. When the engine speed reaches approximately 880 RPM, it operates a small cam under the injector rocker of the arm to make the rocker inoperative, with preventing the injection of the fuel into the cylinders, stopping the engine. The overspeed stop must be reset manually by turning the resetting lever on the counterclockwise direction until the latches. The resetting lever is located on the front end of the engine directly behind the governor. The diesel engine cooling system. The cooling system of several engines of the locomotive are similar to independent of each other. They're designed to operate with the G valve at the level so that when the engine is shut down, the water level below the radiator, thus giving the protection against the radiator freezing during the shutdown. With the cold by the 2 central figure water pumps located with the front end of each with the engine draw water from the water tank, which the water of the part of the water tank oil cooler assembly located overhead with the front end of each of the cylinder. The pump circulates with the water at the bottom of each of the cylinder liner of the cord passages in the liner cylinder head out through the outlet manifold from the engine. The water flows from the 2 group of the radiator section located within the roof of the hatch directly over the H of the engine. Here the water is cooled and then returned through the oil cooler of the water tank. The water tank temperature of each of the system may be checked by the dial type gauge located with each of the water tank. The ideal operating temperature is 165 degrees Fahrenheit. It's recommended operating temperature of 150 degrees Fahrenheit to 180 degrees Fahrenheit to be maintained. Radiator shutters control the flow of the air. Radiators regulate temperature for the air engine cooling water, but the shutters normally operated with automatically pneumatically cylinders, which are actuated with the air supply with the main reserve of the full pressure for the magnet valve. The magnet valves are operated with the shutter relays, which in turn are operated by the engine temperature control switch. The control switch for each of the engine is connected with the calipari tube with the temperature bulb located in the cooling system. When between the engine and the radiator's current with the magnet level, the relays and switch is taken from the PC wire low voltage system through the 6 ampere fuse located in the number 1 shutter relay box. The engine temperature control switch for the engine is mounted with the adjacent shutter relay. The shutter relay magnet valve is located with the right hand side of the unit just below the ceiling sheet. The 3 shutters per unit, but their respectively operating mechanisms include the air cylinder are located overhead on each of the end of the unit. The third between the 2 radiators assembly approximately in the middle of the unit. When the engine temperature control switch on each of the engines closes, the operates corresponding with the shuttering relay closing of the number 1 shutter relay operates the magnet valve which admit air to the operating cylinders and front middle shutters, causing them to open. Similarly, closing the engine temperature control switch, the number 2 engine will operate the number 2 shutter relay. The shutter relay will operate the magnet valves controlling the rear of the middle set of the settle shutters. Its operation, either the shutter relay of the unit will cause the middle set of the shutters to open, but the middle shutter will open as long as either the engine requires the open shutter, the only when the both engines require closers shut and closed shutters will the middle set of the shutters be closed. Its operation, either the shutter operating linkage is connected with the manual operating lever of the latch for the notch quadrant. The quadrant is moved with the action of the air cylinder carrying the manual operating lever with it, and thus operating shutter of the construction permits the manual operating of the shutters, and should any failure of the electromagnetic shutter control system occur during the automatic operation, the manual lever is latched in the closed notch of the quadrant. When one engine is in the line of the idling of the cold weather, it may be necessary to take special action to prevent cooling water temperature failing to low. When the action of the engine open mouth shutter, they may be done with the opening manually operating lever of the engine under the power. One or more notches is required. Such action will minimize the time during which the middle shutters will open. Engine overheads is equipped with 2 radiator cooling fans, one located over each end of the engine. The fan for the V-valve with the driven with the engine throttle sheave and the jack shafts. Their speeds are proportionally to the speed of the engine. The engine high temperature alarm switch is a thermal switch located on the side of each end of the engine control panel, which connects the thermal element of the cooling water outlet manifold of the engine. Is the outlet water temperature exceeds 203 degrees Fahrenheit, the switch is the closed light with the engine alarm. The single lights ring with the alarm bell through the locomotive. When necessary to add water to the engine cooling system, the proceeds as follows. Shut down the engine and open the G valve. The G valve in the cooling system of the number 1 engine is located under the number 1 cooling water tank, and the in-cooling system of the number 2 engine is located in the engine room wall to the right of the number 2 cooling water tank. 2. Water supply units run out of the G valve, thereby the filled pipes located in the roof of the locomotive until the water tanks are side filler pipes located underneath the locomotive frame. C. Close the G valve. Minimum water level number 1 cooling system is indicated with the lower tri-cockpit under number 1 cooling water tank. The minimum on the lever number 2 cooling system is indicated with the line painted on the number 2 cooling water tank near the water level gauge. The engine should never be operated with the water below these levels. If the locomotive is to be left standing with the diesel engine shut down where the danger of freezing of the steam should be supplied with the system, the cooling water system should be drained. The fueling system of the cooling system, each system has the connection of the steam train line through the steam admission valve with the check valve D. Check valve E, which is located with the right front of the corner of the engine floor level. The check valve E prevents the water from draining into the steam train line. Steam can be supplied by connecting outside steam line with the steam train line connector at the end of either end of the unit operating the steam generator. When the steam is supplied with the cooling system, the valve D and G should be open. The valve G must be open with the control designated will be build up and freeze in the radiator. Steam being supplied with the cooling system should not be allowed to exceed 50 pounds per pressure. To drain the engine cooling system, first open the G valve, then open the C valve located below the right hand of the water pump of the locomotive floor. Completely drain and assist in freezing weather. Open valve above and then remove the pipe plunges with the water pump. The pressure gauge for the outlet side of the water pump should be observed periodically. Check for the operation of the cooling system. The high pressure indicates the obstruction of the cooling system, and low pressure indicates insufficient water supply of the pump and the faulty pump. Diesel engine lubricating oil system. Lubricating oil system. Several engines for locomotives similar to the independent of each other. The oil stand stored by the oil pump of the engine is gauged by the bayonet type of the gauge for the oil pan with the left side of the engine. When the engine is running, the age should be shown the oil between low and full. When the engine is shut down, the first filled level of the bayonet should show the system uncharged, but after the engine has been running or shut down, the level of the bayonet should be shown as system charged. The difference when the engine is shut down is due to some of the oil being trapped in the lines and filters in the tank. Oil may be added with removing the oil filter cover, the oil filter tank with the oil, the strainer chamber, the pouring of the required amount through the strainer bucket basket. The oil filter tank is located on the floor of the front of the engine Each engine contains a group of 4 filter elements. The engine lubricating oil system, pressure system, used for the 2, the positive displacement, the gear type of the pump, the combined with the signal unit, with the one pump that delivers the oil pressure lubricating system. The other piston cooling the oil supply with these pumps is drawn from the lubricating oil filter tank through the common suction pipe. A scavenging oil pump is used to draw oil with the engine oil pan through the strainer and pump the oil the lubricating oil cooler to the filters and oil filter tank's strainer chamber. Lubricating oil pump in the unit is centrally on the front of each of the engine, with the scavenging oil pump in the lower left front of the corner of each of the engine. Oil cooler located at the top of the cooling water tank, with the provides for the transfer of heat of the lubricating oil of the cooling water. Therefore, there is a defined relationship between the lubricating of the temperature, cooling water temperature. A dial type of gauge located on the side of the oil filter tank shows the pressure of the oil being delivered to the oil cooler by the scavenging oil pump. The after idle pressure is set for 30 pounds when within hot oil, indicating the dirty oil cooler bypass valve located in the pipe between the scavenging oil pump and the strainer chamber of the oil filter tank, set up to be about 60 pounds, permits the oil to flow directly into the oil filter tank. The bypass valve may operate the high engine speed, the low lubricating oil temperature within the piping cooling restricted as the same, so that the gauge may indicate the pressure of about 60 pounds under these conditions. The 2 dial type of the oil pressure gauge located in the engine control panel. The right hand gauge shows the main bearing oil pressure, and the left hand gauge shows the piston cooling oil pressure. Bearing oil pressure must be maintained at all times. When starting cold engine, oil pressure should be building up immediately. Should rise about 40 pounds with the engine warm, but the pressure should be approximately 28 pounds at the 800 RPMs. Normally, should not drop below 200 pounds. Idle pressure should be at least 15 pounds. If the water temperature cannot be held below 180 degrees Fahrenheit, main bearing oil pressure will be decreased, and the permissible to operate with the pressure of the low as 15 pounds at the 800 RPMs. Piston cooling pressure should be an average of 20-30 pounds at the 800 RPM, to 4 to 8 pounds at the idle with the warm engine, but the piston cooling oil pressure should never be below 15 pounds at 800 RPMs. If the lubricating oil pressure drops below the above limits, the engine should not be continued in operation. A low oil pressure alarm switch connected with the diesel engine lubricating oil system operates for the low oil warning will cause for the diesel engine return to the wide idle whenever lubricating the oil pressure falls. Lubricating oil suction alarm, which switch and connect with the suction side of lubricating oil piston cooling oil pumps, operates in the same manner. Suction strainer becomes clogged and obstructed. Alright, the fuel oil system of the several diesel engines for the locomotive are similar to independent of each of the other one, except for the one fuel supply tank mounted under each of the unit with the locomotive supply fuel for both of the engine of the units. A sight glass gauge located with each of the side of the fuel supply tank of the adjacent with the fuel oil filter. The sight glass indicates the level of the fuel oil from the point of 4.5 inches below the top of the tank to the top of the tank. The dial type gauge fuel is located with the fireman's instrument panel with the cab A units on the bulkhead above the number 1 traction motor blower and on the B units. Air valve adjacent with these gauges must be opened to get the reading should be closed, but the reading has been taken. The gauge is calibrated in inches 0 to 28. Electronically driven fuel transfer pump for each of the diesel engine drawn fuel for the fuel supply sump for the fuel supply tank through the suction line filter with the pumps the oil through the filters to the injectors. The suction filter is a fuel oil suction line below the fuel transfer pump motor. The pump discharge filter is the discharge line fuel transfer pump located adjacent to the pump. After passing through the discharge filter, the fuel flows through a duplex centered bronze filter located with the fuel oil line with the injector's right side of the diesel engine near the front. Each injector has 2 small centered bronze filters for the fuel oil with a pipe connection to the injector. An oil fuel sight glass with the relief valve assembly is located above the fuel transfer pump with the purpose to indicate the condition of the various filter for the fuel system flow of the fuel oil through the system of the control of the fuel oil pressure. The left-hand relief valve is set at 60 pounds, center valve is 100 pounds, and the right-hand valve is set at 5 pounds. The 60-pound relief valve operates to relieve the system excess pressure when the filters and lines on the pressure side of the fuel transfer pump become obstructed, in which case the fuel will flow through the sight glass below the valve. The return of the supply pump, a global valve located in the piping connecting to the relief valve, the permitting the cutting on a 60-pound relief valve. The 60-pound relief valve cut, the 100-pound relief valve protects the system with the same manner, but the pressure bowl builds up to 100 pounds. Fuel will show the sight glass under the 100-pound relief valve. The 5-pound relief valve in the return line from the injector's fuel should be in the sight glass below the valve whenever the fuel transfer pump is running. Individual injector provided for each of the cylinder cam on the camshaft of the injector with the proper time of the stroke, with the injector constant with all the times amount of the fuel oil injected with each of the stroke with control with each of the governor, which was varies the electrical effectively stroke with the injector. The lay shaft may be controlled lever attached to the injector lay shaft at the front end of the diesel engine may be used with the engine down, pulling it toward the wall of the locomotive, nothing moving the lever toward the engine increase with the effective stroke of the injectors. The emergency fuel cutoff valve located on the fuel supply tank and the piping being the fuel between the fuel tank sump and the sump supply can be closed by pulling one of the several pull rings on the unit located as follows. 2. One on each side of the unit in a small box with a lifter cover the adjacent to the fuel supply tank filler. 1 located on the bulkhead of the operating cab of the A unit or on the side wall of the holster positioning in the B units. Alright, electrical power system, main generator. Each of the unit contains the 2 diesel engines at 100,000 horsepower. Each of the main generator with the connector for each of the engine through the flexible coupling. The generator is cooled for the air drawn with the communicator and the fuel of the fan mount with the flexible coupling feed with the 2 motors for the truck directly under the engine. Each main generator is associated with the motors and electrically independently of the other generator as until except from the certain low voltage control wiring. Auxiliary generator. 1 auxiliary generator is mounted on each of the main generator with the belt driven by the sheathing of the main generator shaft with the 2 auxiliary generators on each of the unit operate parallel with both of the engines running and used and charged with the storage battery of the units and supply voltage power. Alright, control stand. The control stand with the engine man position of the A unit with the contained with the throttle lever and the reverse lever. Transition lever is not provided with the class of locomotive, not equipped with the manual transmission with the dynamic transition or dynamic brake. The throttle lever operates electrically with the electro-pneumatic governor control for the engines. The reverse lever operates with the reverse electro-pneumatic control. Reverser. The reverse of 2 motors on a truck with its air-operated reversing switch is located in the high-voltage cabinet. When the locomotive is to be towed, the reverse drum should be locked in neutral during the normal operational locking pin is screwed into the left-hand side of the reverser. To lock the reverse drum into the neutral pin, you should be removed and inserted in the hole on the opposite side. The turn of the drum is neutral position and the pin will engage with the thread hole in the shaft. Traction motors. 1 of the traction motors drive the leading axle, 1 of the trailing axles. Each truck has thorough spur gears, a 25 to 55 ratio. The 2 traction motors on each of the truck are air-cooled with the blower chain driven by the diesel engine. The traction motors are connected with a series of starting low-speed parallel automatic transmission, approximately 28 miles an hour. Parallel with the shunting field with 68 miles an hour. Transition back to the parallel occurs automatically. The backward transition from the parallel to the series that takes place when the throttle lever is placed in the idle position. Alright, high voltage cabinet. The 2 high voltage cabinets on each of the unit, 1 of each of the engine mounted on the sidewall of the rear of the respective engines that contain the following apparatus. 3 main power contactors operated with the air pressure through the magnet valves, 1 series of contactor marked S and 2 parallel contactors marked P1 and P2. The traction motor field shunting contactor, the 2-pole marked M, air operated with the magnet valve connects the field shunting resistor across the traction motor field with the field winding with the shunting of the field operation reverser. The rotary drum switch for the air operated through the magnet valve with the transition relay marked with the VI, controlled by the main generator with the voltage operated for the conjunction with the time delay relay with closed with the parallel contactors during the transition. The relay also operates the shunt field with the battery field contactors causing the later opening during the transition. Your time delay relay. Marking the VT allows the time for the generator voltage to decrease because of the closing of the parallel contactors during the transition from the series to parallel. Ground protective relay marked GR opens with the battery field with the shunt field contactors bring the engine to the idle around the ground or occur with the high voltage system. Relay can be reset with the push and the insulated button on the relay. The ground relay can be cut out in emergency open with a sealed knife, which in the cabinet is done with the ground protection removed. The ground on the lower voltage system will also trip the relay when the engine is started. Your wheel slip relay, marked WSR, compares the voltage of the hence of the speed of the 2 motors of the truck. Its speeds are different, indicating slipping of the 1 pair of the wheels indicate that giving the engine man power, the automatically reduce, but slipping will probably resume if the condition is not corrected. Resistors, certain resistors used for the control power circuits are located in or on the cabinet. Low voltage cabinet. Low voltage cabinet built as part of the high voltage cabinet, but separate doors are provided with each of the engine containing the following: engine starting contactors, marked ST plus and ST negative. Two magnetic type switches used for the crank of the engine of the battery, which close with the start switch is pressed with the isolation switch with the start as in the start position. Battery field contactor, or marked BF, close with the throttle lever with the notches 1 to 8, and inclusive of the supplying the battery power to the main generator. Battery field opens during the transition to reduce generator output. Generator shunt field contactor marked SH closes whenever the throttle notches 1 to 8 inclusively connecting main generator to shunt field with the main generator armature opens during transition to reduce the generator output. Battery charging contactor marked BC closes the auxiliary generator voltage and high enough to charge the battery. Voltage regulator regulates the voltage of the auxiliary generator at 74 volts throughout the operating speed range of the engine. Reverse current relay, marked RCR, controls the operation of the battery charging contactor, preventing preventing battery discharge from the auxiliary generator. Battery switch, charging switch, a hand-operated knife switch which connects the auxiliary generator and associated battery charging apparatus to the battery. Fuses: 1 30 amp auxiliary generator field fuse, 1 60 amp main generator battery field fuse, 1 150 ampere battery charging fuse, 2 100 ampere steam generator fuses, number 2 cabinet only. Distribution panel. One distribution panel for each of the unit is mounted with the cap wall behind the Fireman A unit with the N, the F end of the B units contain the main battery switch, the knife switch, which when open isolates all circuit with the battery except the external charging the receptacles. Control switch, a knife switch which connects to the control system to the battery. Train control speed governor switch, this knife switch with the supply of the battery power with the cab signal, Turian phone, and the headlight with the motor generator set for overspeed and speed governor control light switch. The knife switch with its master switch for all the lights. Fuse test light and test blocks. For the testing fuses, fuse 104 ampere and starting fuse, 100 ampere external charge receptacle fuse, 180 ampere control fuse, 160 ampere train control speed governor fuse. 11 fuses from 10 to 30 amps for the circuits controlled by the switches, the control push button switches, boxes for the engine room lights, and the remote steam generator control. Your battery charging indicator indicates the next charge of the discharge through the battery except for the starting current with the external charging current. Light transfer switch mounted adjacent with the distribution panel connecting the light circuit with the battery with external power source. Control push button switch box. The control push button switch box is located above the engine man's window in the operating cab contains the following push button switches. The cab signal, bright headlight, dim headlight, class marker lights, number age lights, defroster motor, engine order light, attendant call push button control. Completes the multiple unit with the control circuit with the throttle control, the start and stop switch of the engine control, each of the unit with the air shutter relays, with the magnet valve with the alarm bells and lights. Fuel pump completes the multiple unit circuit with the fuel pump, the contactor for each of the unit with all the masters, E with the governor over the magnetic valve, the generator field compared to the multiple unit circuit through the throttle and reverser circuit with the battery field and the shunt field contactors. Your engine control panel. On the engine control panel for each of the diesel engine located on the right side of the wall unit with the front end of the engine containing the following: start switch button for the engine, stop switch button for the engine, fuel pump switch for the both, to low ampere fuel pump for the use of the engine, isolation switch, 2 position switch for the thrown and start with the position engine for the idling speed only with no not provide, power for the locomotive when thrown with the run position engine with the under control with the engine man throw lever. Master E magnet valve control the air supply, A, B, and C valve with electro-pneumatic governor control, opening the circuit of the valve through the opening isolation switch or the fuel pump push button switch or the PC switch with the ground relay lubricating with the switch while bringing the engine to the idle except for the number 5 and number 6 throttle lever position with the isolation switch in the run position when the engine will stop. The gauges, piston cooling, oil pressure main and wearing oil pressure warning lights, low oil pressure, steam boil failure, and hot engine. Fuel pump contactor on number 1 engine control for the unit up only with the complete of the circuit with the fuel pump switch at the both the engine with the control panel, electro-pneumatic governor control. Electro-pneumatic governor control all diesel engine locomotive with the control with 1 throttle lever through the electro-pneumatic control located in the front end of each of the engine. The governor control assembly consists of the 4 magnet valves marked A, B, C, and D and the engine, air engine. Electrical circuits between the throttle lever and the governor controls operate in different combinations. The magnet valve with the magnet valves open to admit the air in the various cylinders of the air engine, which turns the operating with the governor control arm through the suitable linkage of the various combinations of the magnet valve with the result of the required engine speed for each of the throttle position. The airspeed is supplied to the A, B, C, and magnet valve through the master E magnet valve, while D magnet valve has an independent supply of the air supply to the air engine through the D magnet valve, all alone shuts down the diesel engine. Load control, which loads the diesel engine according to the throttle setting provided with the load regulator located on the side of the wall of the locomotive near each of the engine. This regulator prevents overloading of the engine. The engine demands more fuel to maintain the speed with the predetermined setting with the throttle position. Load regulator reduces the load of the engine, reducing the field excitation of the main generator. In the same way, the engine requires the less of the fuel predetermined setting with the balance point. Throttle position load regulator increases the load, increasing the excitation of the main generator. The load regulator of the two principal parts of the pilot valve with the attached with the governor hydraulic rotary valve with the type of the motor attached with the communicator type rheostat, which is the governor battery field circuit. Pneumatic control switch relay. The pneumatic control switch is operated with the switch with the mounted together with the pneumatic control relay, and the node for the A units will switch and tipped with the safety control operation for the air brake, the dead man locomotive overspeed, and by emergency brake application. When the switch is tripped, the relay reduces the speed of the engine to idle except for the number 5 and number 6 throttle lever position. When the engine will stop, shuts off the fuel pumps and lights as the indicating light reset. The switch relay with the throttle lever must be returned to the idle and brake pipe pressure restored. Compressed air system. Each of the diesel of the locomotive drive with the direct current with the two-cylinder air compressor. The compressor has its oil pump, pressure lubricating system, oil level in the crankcase to be checked with the bayonet type of the gauge of the intercooler with between the two stages with a 50-pound safety valve. Main reserve pressure control with the electro-pneumatic actuated governor sets the cut with the 125-pound pressure to cut out with the 140-pound pressure with the main reserve to protect against the excessive pressure with the 165-pound safety valve with the discharge pipe. Each compressor had a 150-pound safety valve located in the pipe adjacent with the main reservoir. Drain located with the intercoolers, the oil sump, the reservoirs, filters, main reserve, the means with which condensation may be drained from the system. One each for the unit main reservoir through the reducing valve set with a nominally 80 pounds supply with the control air reserve layer. The use pipe with the electro-pneumatic governor control of each for the engine pneumatically operated switch in the high voltage cabinets. Control air pressure for the gauge is located in the top of the high voltage cabinet. Cutout cocks are located in the piping to reduce the valves into each for the high voltage cabinets. The control air with the reserve equipped with the drain cock within which condensation may be drained from the reserve. Main reserve pressure is used for the operation of the air brakes, sand horns, windshield wipers, bell ringers, shutters, steam generators, water supply, and fuel supply tank guides for the air operated through the separate reducing valves. The air brake system, the number 24RL brake equipment is used with the K2A rotary valve on the A units. Each of the two trucks under each of the unit is equipped with a 4 brake cylinder, 4-sided vent cutout cocks, each of which for the cutouts are released for the 1 brake cylinder on each side of the truck and are located on the right side of each of the unit. Locomotive operation, inspection preparation for the service. After the locomotive has been properly inspected at the distribution panel, each of the units see that all the fuses are in place and all switches are closed. Engine position with the controlling unit, set the throttle in idle position, set the reverse level and off, set the control fuel pump, close the control and fuel push button switches. At the end of the position trailing cab, set the throttle level to the idle position, set the reverse lever is removed. See that the control fuel pump and the generator field push for the button switches are open. If the diesel engine with the control panel, place the isolation switch in the run position. Alarm shall be sound with the low oil warning light should light. Place an isolation switch in the start position. Close the fuel pump at the start switch with the note that the full flow of the fuel obtains 5 pounds of sight glass. See the manual lay shaft lever near the idle position. Press the engine start with the push button holding the entire engine start. After the bearing with the oil pressure be gave, that indicates the leaf for the 15 pounds place isolation switch in running position. See the proper pressure of the tank, the main bearing oil with the pressure piston cooling oil pressure gauge with the lubricating oil gauge with the filter tank. The low voltage cabinet of each of the engines, see that all the fuses in place for the set, the battery charging the switch is closed. 6. A distribution panel on each of the units. Check the battery charge indicator to see that the indicates the charge of the battery. Move the locomotive road operation. To move the locomotive to close the generator field, push button, switch, and place the foot on the dead man pedal with the release of the air brakes. Place the reserve lever on forward or reverse position and required. Move the throttle lever to the position required and start locomotive on the train pausing in each notch position and starting. Heavy train carry most to be properly control slacking before accelerating. I use a load ammeter. Accelerating a train with a standard start of low speed, the point of load ammeter swinging at the full scale with the primer must return to the left of the red triangle that adds speed increase. When the throttle lever in the 8 notch position, the maximum continuous permissible current is 625 amperes indicated by the red triangle. The operation of the amper loads above 625 amperes is permissible under any one of the following limitations for the throttle lever at 8 notches of the position. Amperes 680 miles, maximum distance 20 miles, 705 amperes 15 miles, 740 amperes 10 miles, 815 miles, maximum distance of 5 miles, 945 amperes 2 miles. No, if unable to operate at below the maximum continuous rate of the rating after the operating under one of the above the overload limitations, tonnage must be reduced to help obtain. Operation without loading ammeter. If necessary to operate without load ammeter, the following minimum speeds maintained for the acceleration to avoid the overload. The 8 knots, 34 miles an hour, 7 knots, 28 miles an hour, 6 knots, 22 miles an hour, 5, 16.5 miles an hour, 4, 12 miles an hour, 3, 7 miles an hour. Throttle over the switch notch position maximum continuous speed of 34 miles an hour per operation speed below 34 miles an hour permissible. Under any of the following limitation with the throttle lever in the 8th notch and position 30 miles an hour to 20 miles to 38.5 miles an hour, 15 maximum distance, 26 miles an hour, 26.5 miles an hour, 10 distance miles, 23.0 miles an hour, 5 mile distance, 18.5, 2 miles an hour distance. Transition. When starting a train, the throttle lever should be advanced to the 8th notch position properly as proper. The train handling with the speed restriction will permit the forward transition from the series to parallel operation will take the automatically at approximately 28 miles per hour with the throttle lever in the 8th notch position. This will indicate the flash of the wheel slip light, and after the forward transition series the parallel has taken place, the throttle lever should not be placed in idle position until the speed drops to 23 miles an hour when the throttle lever must be returned to idle position to permit the backward transition of the parallel series to take the place. One step of the traction motor field shunting takes place and automatically approximately 68 miles an hour is indicated by the increase of the load ammeter reading the backward transition with the field shunting automatically. Isolating the diesel engine. If necessary to isolate the diesel engine, see the diesel engine idling. If necessary to reduce the idling speed through the use of the sleigh shaft manual control lever. Place the isolation switch in the start position. Putting a diesel engine online. If necessary, the diesel engine online with the throttle lever in other than idle position. The movement of the sleigh shaft manual control lever may be retarded manually if the diesel engine comes up to speed gradually when the isolation switch is moved to the run position. Engine emergency stop. Emergency engine stop. Stopping all the diesel engine emergency is accomplished by pressing the button on the end of the throttle lever. Pushing the throttle lever at the stop position to the stop position. The throttle lever must be returned to the idle position, and the diesel engine can be restarted with the operating of the emergency engine stop. Depends upon the control push button being closed. Ground relay operation. The ground relay operator of the diesel engine should be isolated with the ground relay reset with the diesel engine placed back on the line with the operating of the ground relay does not operate the alarm, but remove the power of the traction motor and return the diesel engine to the idling speed. Except with the throttle lever in the 5th and 6th notch of the position, the diesel engine will stop. Under this condition, the diesel engine stop. Low oil warning light will limit light and alarm will sound. Low oil warning light indication. Low oil warning will be given when the diesel engine stop at the isolating switch for the run position. This may be due with the operation for the ground relay at throttle at the 5th and 6th knots over speed stop and lack of fuel. If the low oil warning light is due to low lubrication oil pressure for the high lubricating oil suction, the diesel engine will return to the idling speed except for the throttle lever in the 5th and 6th position, in which case the diesel engine will stop. The operation is due to the lubricating of the failure. Oil failure, checking lube oil levels and crankcase the diesel engine, examining external pipe with lubricating oil system for the leaks before endeavoring to restart the diesel engine. If, however, the low oil water warning is due to the condition other than low oil pressure, high suction, the condition should be corrected if possible. The diesel engine start with the place on the back of the line. Hot engine warning indication. The hot cooling water temperature was the cause of the operating of the hot engine warning to check the temperature indicating with the cool water tank to determine the engine causing the warning. The operator to see the system contains sufficient water for the fans operating. And the shutters are open. Operating shutters manually if necessary. If unable to control water temperature of the diesel engine, should be isolated. When one engine is isolated, idling cold weather, it may be necessary to open the manual shutter lever and any of the other engine on the unit. One or more notches is required to prevent low cooling water temperature isolated engine. Yeah. All right. Notes: when attempting to start the diesel engine, if no fuel appears in the 5 pounds sight glass, see the fuel pump is running. If not, check the fuse's position on the switch of the control pump circuits. If the fuel pump is running, if the fuel pump in sight glass. Sorry, if the fuel pump, the running of the fuel shove the 60-pound sight glass note, not in the 5-pound sight glass, move the handle with the center brass and plex for the filter opposite position. If it does not permit the fuel to flow with the 5-pound sight with the glass diesel engine may be operated with the terminal point where the 60-pound relief valve is cut out. With the fuel pump, the running of the no fuel shove with the sight glass, check the fuel supply, emergency fuel cutoff level, fuel oil line suction line of the pump with the leaks. If the diesel engine does not rotate when the engine starts to push, when the engine start push button is pressed, see that the isolation switch is in the start position. Test the 400 ampere starting fuse on the distribution panel. Check the starting contact of the low voltage cabinet. If the diesel engine rotates because it does not fire, see the lay shift the manual control lever to near the idle position. Check for the overspeed stop of the reset necessary. If the locomotive fails to move with the diesel engine running with the throttle open, see the reverse level of the proper position generated the fuel push button switch for the closing brakes. Relief if it does not overcome the trouble with test the 30 ampere control fuse with the distribution panel in the cab to see that all the isolation switches in the run position. If the locomotive moves more than one, several diesel engines fail to deliver power, the following checks should be made. See the isolation switcher in the run position. Check the control switch, control reverse late relay pressure with the check the ground relay reset with the trip. See that the starting contactors are open. See the test of 60 ampere battery field fuse with low voltage cabinets. When changing operating ends before the proceeding of the end being cut with the control generator field, the fuel pump push button switches should be open with the control and the fuel push button switches at the end of the being cut and should be then closed with the properly since the fuel transfer pumps are shut down while the switches are open. The engine will stop within a few minutes. When low battery conditions exist for the leading the A unit with both auxiliary generators inoperable, the locomotive may be controlled by the operating cab of the unit for the valves. The opening the control fuel pump push button switches on the leading A unit, close the control fuel pump and push button switches on any one of the trailing units. Close the generator field push button on switching leading A unit. Close the locomotive overspeed cutout cock of the leading and the A unit to prevent undesired operation. If the light of the front end required, the full additional steps must be taken. Open all the switch and distribution panel leading the A unit except for the main battery switch when lighting the switch. Open steam generator main switch. Turn off the individual lighting switch of the leading A unit with except for the classes marker lights and gauge light switches may be closed if necessary. Alright, Section 4, Class BP1, General Locomotive.